Beneath the colossal Antarctic ice lies a realm of profound mystery, a hidden world sealed off from our sunlit surface for millennia. Today we embark on an extraordinary journey to Lake Whillans. This is not merely a story of a lake, but a testament to the resilience of life. Lake Whillans rests deep within the icy embrace of West Antarctica. Imagine a landscape so vast and uniformly white that a liquid lake seems impossible. Yet here it is, part of a vast interconnected network of subglacial waterways. Its study is a monumental challenge and an irresistible allure for scientists. These unique ecosystems are potential oases for life forms evolved in darkness. They hold clues to past climates and offer a glimpse into other icy worlds. The story of Lake Whillans is a story of Earth reaching for the stars. Antarctica, a continent of superlatives, the coldest, driest, windiest and highest on average. For centuries, its vast ice-covered surface was thought to be a sterile, unchanging wasteland. But science often reveals a far more complex and dynamic reality. Beneath this formidable shield of white, a secret network of liquid water was suspected, but direct evidence remained elusive for many years. The immense pressure of the overlying ice sheet, combined with geothermal heat, can lower the melting point of ice at its base, creating conditions where liquid water can persist. Early hints came from anomalies in radio echo sounding surveys, designed to map the bedrock beneath the ice. Strange, flat reflections suggested the presence of something other than solid rock or ice. It was in the 1990s that satellite altimetry provided more compelling evidence. Tiny changes in the ice sheet's surface elevation hinted at large bodies of water filling and draining beneath. The formal announcement of Lake Whillans' discovery marked a new era in polar research. To comprehend Lake Whillans, one must visualize its scale. Hidden beneath 800 meters of ice, this is not a mere pond, but a significant body of water. Determining its precise dimensions required ingenious methods, a marriage of remote sensing from above and direct measurements from below. Lake Whillans is relatively shallow for a subglacial lake, with an average water depth of only around 2 meters. It covers approximately 60 square kilometers, an expanse roughly equivalent to the island of Manhattan. This configuration makes it a particularly active and dynamic system. Compared to other known subglacial lakes, Whillans presents a fascinating contrast. Its influence on the wider Antarctic system is potentially enormous, a small cog in a gigantic icy machine. The dimensions of Lake Whillans define a unique and scientifically precious environment. The question that burned brightest in the minds of the scientists approaching Lake Whillans was profound. Could life exist here? Conventional wisdom held that life relies on the sun's energy, captured through photosynthesis. But Earth has shown us that life is tenacious and capable of thriving in the most extreme conditions. The environment of Lake Whillans is indeed extreme. There is no sunlight, ruling out photosynthesis as a primary energy source. The pressure at the lakebed is immense, over 80 times that at sea level, yet life has found a way. The organisms discovered in Lake Whillans are chemosynthetic, deriving their energy from chemical reactions. They are masters of metabolizing minerals and dissolved gases found within the water and sediments. The inhabitants of this hidden lake are predominantly microorganisms, bacteria and archaea. The discovery of such a vibrant ecosystem decoupled from solar energy was a landmark moment. Reaching Lake Whillans was not simply a matter of drilling a hole. The paramount concern was to do so without contaminating this pristine, isolated environment. The primary tool for accessing the lake was a specialized hot water drill. This remarkable piece of engineering uses jets of heated, filtered water to melt its way down through the ice. Every piece of equipment destined to enter the borehole underwent an exacting sterilization protocol. Once the borehole reached the lake, a suite of sophisticated instruments was carefully lowered through the icy conduit. The collection of physical samples, water from the lake's column and cores of sediment from its floor, was a moment of triumph. The methods were as innovative as the environment was extreme. The anticipation as the first samples from Lake Whillans were prepared for analysis was immense. The initial microscopic examinations and preliminary chemical tests began to paint an astonishing picture. The waters of Lake Whillans were not sterile. They were teeming with microbial life. The concentration of cells was surprisingly high, comparable to that found in some deep ocean environments. These were not dormant spores, but active metabolizing organisms. Further analysis, including sophisticated DNA sequencing techniques, began to reveal the diversity of this hidden biosphere. Thousands of different types of bacteria and archaea were identified. The microbes in Lake Whillans were found to be utilizing inorganic compounds for energy. The source of these chemicals is thought to be the weathering of ancient rocks beneath the ice. The significance of this finding cannot be overstated. The discovery of a thriving ecosystem in the crushing darkness beneath Antarctic ice resonated deeply with one of humanity's most profound questions. Are we alone in the universe? Lake Whillans, in its icy isolation, immediately became a prime candidate for such an analogue. Many scientists believe that if life exists beyond Earth within our solar system, it is most likely to be found in subterranean oceans or lakes on icy moons. Jupiter's moon Europa and Saturn's moon Enceladus are particularly compelling targets. The confirmation of a complex, chemosynthetically powered ecosystem in Lake Whillans lends significant weight to the hypothesis that similar life could arise and persist on these icy worlds. The challenges faced and overcome in exploring Lake Whillans provide invaluable experience for designing future missions to these distant ocean worlds. Ultimately, Lake Whillans serves as a powerful reminder that our Earth-centric view of habitability may be too narrow. The tiny microbes thriving in the depths of an Antarctic subglacial lake offer a glimmer of hope for life elsewhere. Studying Lake Whillans is an endeavor fraught with immense challenges. The Antarctic continent itself presents the first and most obvious hurdle. Just reaching the remote field sites is a major undertaking. The logistical operations required to support a research project like WISARD are staggering. The working season is short, confined to the brief Antarctic summer. The technical difficulty of drilling through 800 meters of solid ice with the precision and cleanliness required is a monumental engineering feat. The hot water drill must not only melt its way down efficiently, but also maintain the integrity of the borehole. Beyond the physical act of drilling, the risk of contamination remains a constant concern. The study of Lake Whillans is a high-stakes, high-reward endeavor. Lake Whillans and its subglacial lakes are linked to the Antarctic ice sheets and global climate. Understanding these systems provides insights into past climate changes and future ice sheet behavior. Meltwater feeds these lakes, which can fill and drain, affecting ice sheet movement. Water at the base of glaciers acts as a lubricant, reducing friction. Studying Lake Whillans helps us understand Antarctic ice sheet sensitivity to warming. The initial exploration of Lake Whillans has merely opened a door to a vast, unexplored realm. Future research plans envision longer-term monitoring of the lake and its environment. This could involve deploying autonomous instruments that can remain in the borehole or within the lake itself for extended periods. There is also immense interest in exploring other subglacial environments across Antarctica. Lake Whillans is just one of over 400 such lakes identified so far. A key focus for future biological research will be to understand the genetic makeup and metabolic capabilities of the Lake Whillans organisms in even greater detail. Ultimately, the data gathered from Lake Whillans and other subglacial systems will be integrated into larger models of Antarctic ice sheet dynamics. The ongoing and future research at Lake Whillans promises to continue yielding fascinating insights. Lake Whillans has emerged as a site of profound scientific importance. Its study has pushed the boundaries of exploration and technological innovation. Its most celebrated contribution is the confirmation of a complex, active microbial ecosystem thriving in perpetual darkness. This discovery has fundamentally expanded our definition of habitability on Earth. Lake Whillans serves as a crucial terrestrial analogue for potentially habitable environments on icy moons within our solar system. The methods developed to study Whillans are also informing the design of future astrobiological missions. Beyond its biological significance, Lake Whillans is a key component in the vast, interconnected subglacial hydrological system of Antarctica. Its importance extends far beyond its icy confines. We've journeyed together to the bottom of the world and then further still, beneath nearly a kilometre of ancient ice, to the dark, cold waters of Lake Whillans. We've uncovered its discovery, marveled at its unique chemosynthetic ecosystem, and considered its profound implications, from understanding climate change to guiding our search for life on distant, icy moons. Lake Whillans stands as a powerful testament to the tenacity of life and the intricate, often hidden workings of our extraordinary planet. It reminds us that even in the most seemingly inhospitable places, discovery and wonder await. The story of Lake Whillans is but one chapter in the grand narrative of scientific exploration. There are countless other mysteries waiting to be unraveled, both on Earth and beyond. If this glimpse into a hidden Antarctic world has sparked your curiosity and you wish to continue exploring the frontiers of science with us, I warmly invite you to subscribe to this channel. We have many more journeys planned to equally astonishing and thought-provoking corners of our universe. Thank you for joining me, Arvind Delara, on this exploration of Lake Whillans. The pursuit of knowledge is a shared adventure, and it is through understanding the world around us, from its grandest scales to its most microscopic inhabitants, that we truly begin to appreciate the precious and complex web of existence to which we all belong. Until our next journey, keep questioning, keep exploring,